Hello, my name's John. Today I'm going to make a collet chuck to take me ER32 collets for this box battle lathe. The first measurement is the pitch of the thread. I know it's 8 threads to the inch. I've got a thread gauge there. I'll get a close up of that. I don't know how well you can see that, but that's a 8 threads to the inch gauge. It fits in perfectly. There's a 9 which doesn't fit. Nearly fits but doesn't. The 8 fits perfectly, so we know that it's an 8 threads to the inch thread. The next thing we need is a diameter. The thread's important, but all the thread does is hold the chuck on. The chuck actually lines up on this register here. That's the important part, that face and that diameter there. So we need an exact size for that diameter. We've only a say is 1.5 inches. We'll try it with a micrometer. That makes it it's 1/3 under 1.5 inches. We'll try another micrometer. And that says 1/3 under 1.5 inches. It doesn't matter. The micrometer could be 4 or 5 thou out, as long as you use the micrometer, the same micrometer to make the template for that. So what I have to do now, I have to turn a bush the same size as that. So when I come to machine the threads in the register on the collet chuck, I've got something to try into it. It's a micrometer I got given. Old engineer who retired. I'll put a test piece in. And the micrometer is actually reading, dead on. Unfortunately the little ratchet at the top is missing. It was missing when I got it, so you just got to do it by feel. That's actually spot on. Yep, spot on. I'll try my other 2-inch micrometer, which should be the same as that, because I was getting the same reading off this mic as I was off the big one. Yeah, absolutely dead on. I've already got a test piece for the thread. It's an adapter I made a while ago so I can mount the chuck on a rotating table. Trying to chuck off the lathe. That's the thread. I'll measure the register on this one, the homemade one. It's 1/3 under 1.5 inches. It's the same size as that. So I need to machine a bit of bar down to 1/3 under 1.5 inches to be a tri-fit in the collet chuck. That's the register there it fits into. Threads, that face there, butts up against there, and that diameter there is a perfect fit on there. That's what keeps a chuck running concentric. When you come to put your chuck on, you must make sure the register is clean. A piece of board on the bed of the lathe means if you drop the chuck, you won't damage the bed. On the chuck, you make sure it's clean. Always put a drop of oil on, engine oil. Start the chuck. That's all it takes. I found a bit of metal to make a plug gauge out of, a bit of hexi bar. It's not running very true. One of my favourite tools. As you can see, it's running out. Gently fetch the tool in. It's just a bearing on the end of a shaft. Gently push it. That's running through. I could put a clock gauge on there, I'm going to show you it's running dead through. That's the tool, that's all it is. A shaft with a bearing on. Makes a good edge finder for the mill machine as well. I've shown it on one or two of my videos now. The tool I'm using, it's a right hand knife tool. It probably does 80% of all turning work on a lathe. It's a tip tool. I've machined it down so it's round now. The measure of it. .7 inches, so it's got 200 thou to come off. Tenth thou. Zero the dial. I'll take 3 thou. That should take 6 thou off it. Measure. Four thou of that size. Thou and a half. Should be 3 thou. We're getting near now. What I'll do, I'll try and get this size. I'll try and get this side the right size. If I go under, it means I can use that as a trail gauge for underside, so I can turn it round, do the other side. Thou and a half too big. Dead on 1.5 inches. Not quite. I'm going to take another cut on the same setting. It's half a thou, under 1.5 inches. That's a good fit. We'll settle for that. I'll take one more cut, same setting. Just put a little chamfer on the end. Just a little touch with the emery tape. That's nice. And what I'll do, I'll turn it round and I'll machine the other side to be say 2 or 3 thou smaller than that, So I know when I'm machining my chuck, I can get that in and I've got 4 or 5 thou to go, get it somewhere near. I've turned it round, machined the hex off, we'll have a measure. This time we are 7 thou, over 1.5 inches. Zero my counter. 7 thou. I'll take a 4 thou cut, as I want this one smaller. 4 thou aside, that should be 8 thou. It's actually dead on the side I need. So what I'll do, I'll take a 5 thou cut off that, which will make a 10 thou undersize. 5 thou. Yep, that's 5 thou under. So what it means now, when I come to machine the chuck, I can machine it, and when that goes in, I know I'm getting near the size. So I can machine it out, that goes in, I know then I'm within 5 thou side of it being the right size. Just put the chamfer on. It's quite a universal tool, this. Little chamfer. Take one with the emery tape. I'll mark it. I know that's a small size, small side. What I'll do, I'll stamp it. I'll put some stamps on, US undersize. So what we've got now, we've got that side, we're getting near. We've got that side, which is dead on size, spot on. It's actually very, very slightly warm, so when it cools down, we're going to be in the ballpark. So now we've got our 2 gauges. We've got our ball gauge. We've got a thread gauge we made earlier. That's a bit of bar I'm going to use to make a chuck out of. It's a bit of AN8, nice steel, good to machine. I'm going to machine it in a 4-jaw chuck. The 3-jaw chuck is accurate enough, but you get a much better hold of it in a 4-jaw chuck. Remove this chuck. One way of doing it. Bit of hexi bar. The spanner that fits it. The lathe has got a spindle lock. Off your comes. Every time you take a chuck off, you must clean the end of the spindle and the register in there. A few drops of oil. The chuck will actually tighten on as you're using it. Bit of bar I'm going to use has actually got a centre drill in the end, centre mark at the end, which is handy. Trying to get it somewhere near. Yeah, but not near enough. We'll put the centre of the back in, and we know that bit's going to be straight. One at the tip, you put something white underneath. When you look down, you can see a lot better against the white background. Just about there. Yeah, enough. I could put a clock gauge and get it absolutely spot on, but it's going to be machined anyway, more for balance. Very good. We're too long for what I want, so I'm going to part it off. All I need is 3 inches. Where have I heard that before? All I need is 3 inches. Mark 3 inches. Just under 3 inches, I'll be able to get toe to this. We've got a mark. I'm going to part it off. It's a commercial parting tool in a homemade holder. 2 things with parting tools is they must be on centre height and they must be square to the job. I know the tool's square in the holder, so if we put the tool holder square to the end of the workpiece, loosen that off, feel it. Tighten it up. So we know the tool is square to the job. Now we're going to set the centre height. There's a few ways of doing centre height rulers. The best way is to take a cut off the end of the bar and make sure it doesn't leave a pip. This method works. Put a lathe centre in. Looks good. Right, when you're parting off, everything must be in close and tight. As little overhang on the tool as you possibly can. Obviously the bar's hanging out with the chuck quite a long way, but I have got a centre in. I can't part it all the way off with a centre in, but I can get most of the way through it. So our tool's set square to the job. It's on centre height or very slightly above centre height. Put our mark. What was it there? 3 inches. And we've got enough to make another one. We'll lock the carriage so it can't move. What a lot of people do when they start parting off, they start cutting and it starts to make a noise. Most people back off. Don't back off, wind the tool in harder, make it work. If you back off, you'll snap the tool. It doesn't always work, but I've found, be bold, be brave. This lathe's got cutting water, got white water on it, I'm going to use it. Once it starts to cut, keep going and don't back it off. So I'm running back here, we're running at 66 RPM. It's cutting quite nice. Keeping a constant pressure on it. Plenty of water. If it takes us 20 minutes to part it off, it takes 20 minutes. I'm not in a hurry. I'd rather do this is cut it by hand with a hacksaw. You mustn't forget we're working on a small lightweight lathe. Once I get sort of 2/3 of the way through it, I'll speed it up one gear. Obviously the surface speed of the material slows down the deeper you get. One thing, parting a bit of brass bar, a bit of aluminium off. We'll try something like this test jig here. I've got a rear tool post, which I've tried with the tooling upside down, and I found it actually worse than this. The design of the lathe, the box fat, where the carriage is held down is not very good. It actually lifts up at the back. They're a good solid workhorse of the lathe, but there's one or two design faults with them. But there's nothing the matter with that. It's just about there. See, I can't go all the way through with the tailstock centre in. Maybe half an inch left to go, if that. I think that'll do for me. I threw just under 1.25 inches. 2.5 inch bar, so we're nearly all the way through. Finish it off with a hacksaw. Favourite tool, bed protector. The one time you don't put it in, you'll go straight through and right into your bed. Quite a nice finish as well, not bad at all. In fact, it's a good finish. Nothing wrong with that. Centre drill the end. Nice big centre drill. You need to drill all the way through here anyway. Now the biggest collet I've got is 20mm, so I need at least a 20mm hole. Right. The lathe spindle's got a 3/4 inch 19mm hole, so we'll be poking a big drill through that. On a bigger machine with loads of power, you go straight through with a big drill. Run this 1/4 inch 6mm drill first. Keep backing your drill out, chippings of it, put a little water on. Last time all on the camera. Once you get a hole through, it's not too bad. The chips come at your end as well. It's a nice neutral. Keep stopping and keep snapping the snapping the shavings off. Horrible nasty sharp things they are. Right, we're through now. We'll dispense with the drill chuck. Start with a ball shape like here. With a 3/4 inch drill here. Back here, plenty torque. Nice and slow. You hear the machine working. Got that for. I haven't managed to break it yet and I've tried hard. Taking a big, that's a big cut, that. Big nasty horrible shavings coming out of it.